I want to give you as much time as possible for the quiz today. Get going. Anyone else still going? Okay. Thou shalt not have square root on denominator. That includes imaginaries. So, how am I going to get rid of that because it's part of a whole expression? Multiply by a conjugate. Frank? Wait, I wonder. No, I took my... Yeah, that's what I thought. I brought the laptop down to the tech office to have them update the stream software. So it's got to remember that Frank is over here, not over there. There we go. Okay, let's try that again. Because it actually wrote over there. By 6 plus 2i. 6 plus 2i. Distribute. We got a 42 plus 14 i's plus 30 i's plus 10 I squareds. Then we have a 36 minus a 12i. No, it's plus. Then minus 12i. Minus 4i squared. There we go. We know that I squared is negative 1, so this is really minus 10. I squared is negative 1, so this is really positive 4. We know that those terms cancel. So it's just a matter of combining like terms. 42 minus 10. 14 i's and 30 i's. And 36 plus 4. Be careful what you do from here. Don't reduce like a freshman. They're both over 40. Reduce them both. 32 over 40 reduces to 4/5. 44 over 40 reduces to 11 tenths I. Separate your real friends from your imaginary friends and simplify them both. So here's what I mean. Like, I'll see kids do, I don't know, they'll do that. And then just write 4 plus 44i over 5. Bad. I'll see kids do, okay, maybe they take 4 out of each, like that, and they leave it as 8 plus 11i over 10. Not wrong, but also not right. Like, this is a correct statement, but we still haven't simplified as far as we can because we still haven't split our real and imaginary number. So, normally I'd be all about it. Go ahead and do that. I don't care. But we have made such a big deal out of this in the last few days. That's where we want to go. Okay? So, stage 1. Did you multiply by the conjugate? Did you even have the right conjugate to begin with? Stage 2. Did you get the correct distribution, both numerator and denominator? Meaning specifically, you didn't just cancel out the denominator and say it goes bye-bye. I see kids do that. Don't do that. Did you combine like terms correctly? and then simplify it correctly. Okay, so the correct conjugate, correct distribution, correct combining like terms, then simplifying the complex number. Get him, Mama Bear. What else we got? Anything here? Going okay? All right. Then, bye-bye. Bye-bye. Bye-bye? Question mark? I might have to just restart the whole thing because I dared to disconnect my computer and then reconnect it. I should have restarted it before we... Yeah. I should have restarted it before we got going here. No. Oh, that's why. Okay. Well, no one asked anything. How we doing? Seriously? Like, nothing? If Frank lets me. Whoop. If Frank lets me. $62. Oh, sum and product of the roots. So stage one, you have to solve it. Quadratic formula or complete the square, however you're gonna. But when you get to your answer, a plus or minus bi, the sum and the product of the roots says take a plus bi plus a plus b or minus bi, add your two answers, product, multiply your two answers. So you solve it, and whatever your two answers are, you add and subtract the two answers, or add and multiply the two answers. Find the sum and product of my roots. So, negative 1/2, half, 2/5, 1/5, 1/5 squared, 1/25, 1/25, 25, negative 25. Oh, gross. Negative 50 to negative 48/50ths? No. I'm cross-eyed because I actually just kind of passed out, drooled on the bed last night, so I'm still not right. All right, we're gonna do this because I can't think. The ability to think has disappeared, so use formula. Two A, there we go. So negative 2 plus or minus 4 minus 20 is negative 16. Square root of negative 16 is a 4i over 10. So negative 1/5 plus or minus 2/5 I once reduced. Find the sum and product of the roots. So if those are my two roots, my two zeros, my two x-intercepts, take negative 1/5 plus 2/5 I plus negative 1/5 minus 2/5 I. The sum of the roots, which will just be negative 2/5. Make sure you turn your phones off before you come to class. It's Navi. There we go. And product of the roots, the same thing, but you multiply them. And since they're conjugates, we actually know that's going to be 1/25 minus this thing squared. So 4/25 I squared, and I squared is a negative 1. 5/25 is 1/5. So you'll get negative 2/5 for the sum, 1/5 for the product. They're showing you that when you have conjugate roots, all the I crap goes away. Yeah. Okay, so besides that one, anything else? Okay. Then review. All right. If you don't want to be getting up and moving shop after the review, scramble yourselves right now. Don't sit next to anyone that you would normally sit next to, or I might have an issue with. Move around. Okay, basically, y'all are good, except you two and you two and you four. Move. Because y'all a bunch of knuckleheads, and you know it. You take pride in it. If you want to, but it's open notes and open everything for the quiz, so.
Are we turning them back? No. After school, my room's loud because the game club is pretty loud. If you were around with this, I think you've got
Okay, y'all squiggled around here, ready to go? Okay. So, what we got to do here? I have to. There we go. So, we have done completing the square, quadratic formula, and complex numbers in the last 5 days. Start with complete the square. Do you remember what the steps are? Step 1. What?
No.
I mean, if I'm factoring, yes. Okay, remember that 1 and 2 were interchangeable, or you could even do them at the same time. But divide by A. So I'd have x squared minus 5x plus 5 halves. And then when I complete the square, the idea is to have a perfect square trinomial. if I'm going to have that, that 5/2 is in the way. So I'm going to do variables left, constants right. Meaning that guy's in the way, get him out of here. Now keep in mind that subtract it over there. It doesn't just poof. Okay. Then I need to actually complete the square. And that perfect square number is always the same thing. It's what? B over 2 squared. Okay, make sure that you add it to both sides. It's really common for kids to find the perfect number, but maybe it's like a fraction or something, so they get distracted by ew, and they just forget to write it on the other side. Make sure that you add it to both sides. So half of -5 is -5/2. Go to fraction town, don't go decimal town, and then squaring it becomes easier because now if I take 5/2 squared, I just square 5 and square 2. Get 25/4 on both sides. Now that this thing right here is a perfect square trinomial, I can write it as a factored form of a binomial squared, which is, now I can write it as x plus b over 2 squared is some number. And it's always going to be of that form. Whatever that number in the binomial is, it's going to be half of b, and it's going to be the square root of c. That's what makes it perfect. So this is now x minus 5/2, the quantity squared. Some kids will get a little goofed by, but you said plus b over 2. Why is that minus? Well, what is b in blue? Right? So I'm adding a -5 over 2. I need common denominators. By 2 is a -10/4 plus 25/4 is 15/4. And that's the reason that we go to fraction town. Because if you instead of that had 3.75, do you off the top of your head know what the square root of 3.75 is as a simplified radical? No. Ew. So instead, I would rather solve by square roots using that fraction, because the square root of 15 can just stay square root of 15. That's as simple as it gets. But the square root of 4 is nice. Square root of anything squared is just that, anything. And plus or minus. I put the square root there. If you're ever dealing with something that already has a radical in it, you just work with it as is. It's called the principal root. But if you ever put the radical there in the process of solving, you have to cover all possibilities. That's where the plus or minus comes from. So at the end of this, I get 5/2 plus or minus square root of 15 over 2. And you do want to leave them separated. Just like we separate real friends from imaginary friends, we will also separate your rational friends from your irrational friends. Okay? Your friend that's probably going to get you end up in jail over the weekend, maybe don't invite him over. Okay. Are we okay on this? Do we have our steps written? Is there anything about the steps that maybe we should write something next to it? A reminder that helps you? Is there something that you always think when you're doing this? Is there something that, a way that you write it differently? Maybe you use a little arrow over here, or you underline this thing. Is there anything that you can do that will help you with this? Do it. You get to tell yourself how to do the problem. You're still going to have to do the problem for a quiz, but I want you to be as supported as you can. We all cool? Okay. Then we're going to like dumb Frank mode here. There we go. Now specifically with the quadratic formula. Notice the difference on 1 and 2. They do specify do it this way and do it this way. Again, that's the standard that I have to assess. I have to assess students are able to solve complex polynomials with multiple appropriate methods. So I have to test all the methods. Quadratic formula, if you don't know it, negative b plus minus b squared minus 4ac, square root of that thing, all over 2a. It is also above Callister's head. It is also in your notes. It is also on your holy sheet. If I'm going to set this up, what did we say would be a good idea? Before I just start writing numbers. Parentheses. Parentheses should help keep us from screwing up all of these negatives and exponents. Then plug stuff in. Say b is 6, a is 7, c is negative 2. The parts that I'm able to do together are what is outside, what is on my denominator, and then if you want to do this in one shot or you want it in 2 separate pieces, it's your choice. Here I have negative 28 times the negative 2 is 56. 36 plus 56 is 92? Question mark? Okay. So far, you've done everything correct. If I'm looking at this on your paper, I'm going to say they got the formula correct, they put the things in the correct spots, they found the correct values of simplifying those 3 locations. 3 out of 5. We haven't finished. I need to simplify the radical. So what's the biggest perfect square that goes in 92? I heard 439, mutter, mutter, grumble, grumble. Okay, if I have no idea, well, I know it's divisible by 2.
24.
I know that's divisible by 2. And Rutrow, 23 is prime.
So you take out the 2s.
So I can go old school like this if I got no clue what's going on and say there's a pair of 2s, one comes out. Or if you recognized 4 by 23, square root of 4 is 2. So now we're at negative 6 plus or minus 2 root of 23 over 14. Okay, now we're at a 4 out of 5 because you simplified the radical correctly. You got to finish it off by separate your real friends from your imaginary friends and make sure that you simplify each of them along the way. Negative 3/7 plus or minus square root of 23 over 7. Okay. It's not enough to run it all the way to the end zone. You got to do your little happy dance.
One sec. Yeah. He didn't see it, so he wasn't going to see it.
All right? You got to stop me. All right. Cool? Okay. And get over here. What? No, no. What are you doing? Stop it. Okay, simplifying kind of sounds like an oxymoron. Simplifying complex numbers. Step 1. We just did it in our daily quiz. Multiply by the conjugate. Okay. Once I'm there, okay, you have the correct conjugate. 1 point. Now, can you distribute correctly? Getting 2 minus 6i, 2 times the stuff. Negative 4i times the stuff is negative 4i plus 12i squared. So there's your second point. You distributed the numerator correctly. Distribute the denominator correctly to get the third one. 1 times the stuff is 1 minus 3i. 3i times the stuff is positive 3i minus 9i squared. We know that I squareds are negative 1s. So turn that to a negative, turn that to a positive. Combine like terms. Say 2 minus 12, negative 10. Negative 6i minus 4i is minus 10i. Oh, forgot those cancel out. 1 plus 9 is 10. Do not freshman math. Y'all, the number of times I see a kid do that, bad. They are both over 10. Okay. Math is communist. What you do for one, you do for all. If you can reduce them right now, like that. That's fine. It's still going to be negative 1 minus I. Or it's negative 10 over 10 minus 10 over 10I. And then simplify it. I don't care how you simplify it, just make sure that you follow math law when you do. No, still not working. What can you tell me about the directions here? Like, it just says solve. Doesn't say how. So you solve however you want to. If complete the square is your jam, do it. If quadratic formula is your jam, do it. I'll tell you right now, it's not factorable. Because there are no factors of 48 that add up to a negative 6. I don't think. No? No. Okay. So, for our complete the square fans, I'll divide everything by 4. And move my constant to the other side because I'm feeling it. Divide everything by 4. Move the constant to the other side. Add b over 2 squared to both sides. What is half of 3 halves? 3/4. Just double the denominator. Okay? So if I take that 3/4 and square it, I get 9/16. The socket that no one can ever find. That's now a perfect square trinomial. I'll factor it and say x minus 3/4, the quantity squared. I'll get common denominators here, times 16 times 16. Negative 48/16 plus 9/16 is a negative 39/16, right? Yeah. Square roots. Bring everything over to one side. 3/4 plus or minus square root of 39 over 4i. And I will put the i out at the ends because I want it to be bi if we want to be formal. Option 2, I don't want to do any of that. Screw it. Formula. Negative b plus minus square root of b squared minus 4ac all over 2a. Plug in there. B is negative 6. A is 4. C is 12. U. So a negative 6. 6. 4 by 12 is 48. 48 by 4 is 96, 192. So plus minus, and then 36 minus 192. Negative 160, 156 or 4? What?
Negative 156.
Um, 156 awful close to 160. That would have a 16 come out. Duh, I just did it here. 39 and 4. I am so smart. SMRT. 6 plus or minus square root of negative 1 by 4 by 39 over 8. So I have 6 plus or minus. Square root of negative 1 is I. Square root of 4 is 2. 39 stays inside. All over 8. Separate your real friends from your imaginary friends and reduce. Honestly, it's the same number of steps. It's just some people would rather just formula plug and chug because that's their jam. Do it. On this problem, I don't care how you get there so long as you follow math law. Okay, what's that? 4 this way. F's in chat. Fully factored form. What's the first stop on the factor train? Lies. No. I know GCF. I'm asking what is it? I know what it is. Do you? Well, yeah, but let's take our GCF out first. It is just 3. All right, those look a little more familiar. Okay. If that was 16x squared minus 49, we just square root and say 4x plus 7, 4x minus 7. What is different because it's sum of squares? I's. That's it. That's the only difference because it's sum of squares instead of difference of squares. We did quite a few extra practice problems with these. Are y'all okay if those weren't perfect squares? Because I honestly don't remember what I have on the quiz. What if that was 16x squared plus... 27. Okay. 27. It's still 4x like this, but it's just the square root of 27, which 3 squared to 3, make sure you simplify it. You'd have plus 3 root of 3i and minus 3 root of 3i. You just have to simplify it if you can. I don't think that's the case. I'm pretty sure that I made sure all of these forms had nice numbers after the GCF, but you got to be ready for it just in case I mental math wrong. So, stupid dragon. Okay. And because it's been a hot minute, I ain't even going to do anything. You figure it out. Review. You're going to start seeing this more and more. We're about halfway through the semester. So we're going to start bringing back old stuff. You're going to be in the middle of radicals and logs in another 2 months. And I'm going to bring up stuff about quadratics. Okay? Let's see what you remember. Man, that'd be awesome if this was open notes, open everything. Section 2.4. Like, that would just be great.
That's crazy. Only it was. Oh, wait.
I think it's 2.4, I'm not sure.
Oh, that's M.
Come on now. Get those review skills. Okay. About halfway through the semester, expect that we're going to start doing this on the regular. Where every time we have a quiz, that last problem, odds are it's going to be a review problem. Come on now. I'm not sure if it's in 2.4. I remember we did parallel and perpendicular lines somewhere in chapter 2. I remember 2.5 was models. 2.6. Okay.
What? It's a perpendicular. You already have a slope of x.
Now we see who just writes down the thing that we did in class and who put notes next to the thing. Your tattoo there, bud.
Oh.
Was that when the kids in pre-calc came in a few weeks ago with a big old whiner drawn on the back of his arm? He had no idea it was there.
A big old what?
Whiner.
Why?
Okay. So, what does the word perpendicular mean?
Like 90 degrees across.
Creates a 90-degree angle. How does that work in terms of slopes and lines? I like the vocabulary. Negative reciprocal. Instead of like flip it opposite thing. Okay? Perpendicular. The slope is perpendicular to the negative reciprocal. So if I want to be perpendicular to this line, the only thing I care about is the slope. That's all I care about. So what is perpendicular to 5/4? Negative 4/5. And it gives me a point. So it would probably be best to start in point slope form. I got y minus y1 is, now I know my slope, negative 4/5, x minus x1. So y minus 13 is negative 4/5, x plus 8. Distribute. Negative 4/5 x minus 32/5. Add 13, which is 65/5, so 33/5. Negative 4/5 x, right? Like, check me before I wreck me. Okay. Plus 33/5. Ew. Okay. To which I bring you back to geometry. Do y'all remember? Find the distance between two parallel lines. This is why it got weird. Because you would pick a point on this line, you'd have to make a perpendicular line through it so that this was also perpendicular. Because if they're perpendicular, that means the distance formula now applies. But in order to find this point, you would have to do a system off to the side to find the intersection between the two lines. And once you had the 2 points, then you would distance formula. Womp. But what happens when you do all of that and you end up with gross, disgusting lines? What happens when the coordinates got fractions in them? No, you just do the formula with gross numbers. Y'all big kids, deal with it. Okay, yes. And someone caught it before I gave you the quiz, yes. Because it just says write an equation. Oh, wait. There you go. Right? At purple, that is a simplified equation that is perpendicular. Done. Okay. I don't have to take it all the way to slope-intercept. Could I also go to standard form? AX plus BY equals C? Could I do standard form with integer coefficients? All of the above are still correct answers. I don't have to. Yes. I added 13 over, and I plugged negative 32 fifths over, or negative 32 fifths plus 13 into my calculator. Because 13 times 5, 65 over 5, 65 minus 32 should be 33. But then I'm also like a week and a half straight now of 5 hours or less sleep. So my cognitive function is just, which is why I say check me before I wreck me. Y'all good? Cool. Let's do this. But before we do the thing, I only see 3 devices over here. Please make sure they're off so you don't randomly have Navi telling you, hey, listen, in the middle of a test. No vibrate mode, no bzz, bzz in the middle of our quadratics. Okay, make sure it's off. Be courteous to the other people who are working. And you got lots of time. You got like over a half hour. Okay, so plenty of time to get her done. Reminder, when you are done, we are halfway through the semester and people are still screwing this up. Quiz in basket. Not notes in basket, quiz in basket. Everything else in pile next to basket. Not spread all over the counter, in pile next to basket. Okay? All right, let's do this. 1, 2, 3. 1, 2, 3. 3. You're good to go. Yes, I'll just go through them after you turn everything in. You're like a week early. And this goober. All right. We all got it? We're there? We're good? You're free to go. Here. 4. And there's your 4 notes. You're going to need those to do your quiz. Okay, just take whatever you need. Okay.